Assalamu alaikum. Dear learners, in this video lecture series, I am going to explain various mediums through which signals can be routed if you are considering instrumentation and measurement systems. Till now, we have studied about various types of instruments and various signal processing techniques that can be implemented to pre-process our signal, which is being generated by those instruments. In this lecture specifically, I will talk about common practices in an industry through which signals are routed between various components of an instrumentation and measurement system. These components can be the sensors, the signal processors, storage devices, the display devices, whether they are in form of HMIs or a simple display unit. And there are many other devices that needs to communicate with each other. Once the signal has been generated by the sensors, they need to be routed from the sensors to the subsequent components which have been attached for various purposes. We have studied various noise removal instruments, calibration equipment, control systems, etc. that requires the input from the sensor and produce a suitable output. We have already discussed in detail that if you are going to route a signal, then it may be corrupted because of a number of reasons. Apart from implementing all that we have studied under the topic of reduction or mitigation of noise, one important thing is to use a suitable signal transmission medium so that the integrity of the data can be ensured. If I specifically talk about industrial environments, then a signal moving in various signal wires is prone to induction of errors from sources like magnetic fields coming from large electrical machinery and power cables, fields induced because of wiring loops, a large voltage transient that may affect the whole electronic circuitry whenever large AC power supply turns on or off, or there might be many other sources which we have touched in previous lectures as well. Till now, we have discussed that how we can mitigate the noise once it has corrupted our signal. But today we are going to see that how we can best utilize the communication or the signal transmission medium to reduce the chances of induction of such noise. Basically, there are four different transmission mediums that are being used in industry quite extensively nowadays. The first one is the electrical transmission of signal. This method utilizes the flow of electrons, or in other words, you can say voltage or currents, to relay the information from the sensor to the attached signal processing units and the control units. The second method is to route the signal using pneumatic means. This method utilizes pressurized air instead of electrons. During your course on basic electric circuits and physics as well, you must have established an understanding that a voltage in an electric circuit is analogous to pressure in a pneumatic circuit. Therefore, if voltage can be used to transfer a signal between two instruments, then why not pressure? Pneumatic systems normally use pneumatic pressure to transfer information between the two connected instruments. Pneumatic systems normally use this pneumatic pressure to transfer information between the two connected instruments. After that, the third and the fourth transmission medium both utilizes electromagnetic waves to transfer the information. One way is to use unmodulated electromagnetic waves that can be from any band of the whole electromagnetic spectrum, whereas the other way is to use a modulated electromagnetic wave. The use of unmodulated electromagnetic waves is confined to the visible spectrum or sometimes the IR spectrum. However, sometimes electromagnetic waves belonging to higher frequency portion of the spectrum are also used. The case where the modulated electromagnetic waves are used is specifically called radio telemetry. This method normally uses radio waves and sometimes microwaves as well, and transfer information by modulating the signal using radio or microwaves. No matter which kind of signal transmission medium is used, all mediums can carry either analog signal or digital signal. It depends on the application whether you want to route the analog signal or the digital one. However, some transmission mediums favor analog signal transmission, whereas the other favors digital format of the signal. Let us start with all signal transmission mediums one by one and try to cover the basics as we go. The first transmission medium that I am going to focus at is the electrical transmission medium. Probably the easiest way to transmit analog voltage is to use the electrical transmission medium. However, this medium has certain cons associated with it, which we have already discussed under the heading of noise removal and associated problems. Normally, voltages are transferred using signal wires, which requires efficient signal processing techniques and shielding of the wires to protect the integrity of the signal. Although this scheme is the easiest one, but is the most noise and error prone scheme. Therefore, this way of transmission of signals is only utilized in a very low cost application or where the signal voltages are considerably higher than the magnitude of the noise that can be induced in the signal. For example, for turning on or off the lights or any other electrical equipment, simple voltage signals are used because in this case the voltage running in the wires is quite large and cannot be affected by the noise which is present in the surrounding environment. However, if in the same environment an equipment that is generating a low voltage signal is used, then the low voltage signal can easily be corrupted and therefore cannot be efficiently routed around that environment. In such a case, we have to look for some other ways to route the signal. Probably the most used electrical transmission method for transmitting signals in an industrial setup is the use of current loops. This method utilizes the amplitude of the current instead of the amplitude of the voltage to transfer the information. One direct advantage of using current instead of voltage signal is that signals will not be attenuated by the resistances of the conductors or the junctions between various electrical outlets. Because we know that a voltage will drop as we increase the resistance, but if we have allowed some current to flow in the circuit, then that current cannot be reduced no matter how much resistance it is facing. As an industrial standard, the current range between 4 milliampere and 20 milliampere is used to represent all the analog voltage levels. To achieve this current output, a voltage to current converter, commonly known as 4 to 20 milliampere current loop interface, is used. In order to maintain the current in the electrical circuit, voltage controlled current sources are used. Depending on the input voltage, these sources will provide a constant current no matter how much resistance that current is facing inside that circuit. For achieving the industrial standards of 4 to 20 milliamperes, two voltage controlled current sources are used. One source will provide a constant 4 milliampere, which is used as a power supply current or is used to make sure that everything is working fine. The second voltage controlled current source is used to provide a variable 0 to 16 milliampere current signal that is scaled in proportion to the input voltage level of the signal. Currents from these two sources are added up, hence making total current in the range of 4 to 20 milliampere. Now 4 milliampere will represent the lowest voltage level generated by the sensor, whereas 20 milliampere will represent the highest voltage level coming from the previous part of the system. Another method for transmitting electrical signal is the use of the modulation techniques. In this technique, low voltage DC signals or sometimes analog signals are transmitted using AC carrier. Over here, I would only mention the names of the two modulation techniques that are commonly used for this kind of transmission because I will explain these techniques in detail when I'll discuss the radio telemetry in the same lecture. The two most commonly used modulation techniques are the amplitude modulation and the frequency modulation, abbreviated as AM and FM. Yes, this AM and FM is exactly what you have in your radios. The whole radio network is utilizing these kind of modulation techniques to transmit data from their local stations to your radio devices. I will talk about these things in detail under the heading of radio telemetry. Let us now talk a bit about pneumatic transmission methods that may be used to transmit signal in an industrial setup. In these systems, the analog signals are routed as change in pneumatic pressure normally in the range of 3 to 15 psi. The initial signal is normally a voltage or a current signal that is converted into a pressure signal using suitable actuators. The main advantages of using pneumatic transmission are the safety aspects and the noise immunity. As compared to the voltage or current signals, pneumatic pressure signals are much more safer, especially at the pressure levels that are used in industrial standards. Moreover, all the problems of noise induction in voltage signals specifically are not present over here. However, on the other side, the disadvantages include low speed of transmission and a drop in pressure or the pressure gradient that may easily develop around the pneumatic circuit. You may compare this thing with a voltage signal that may drop around the circuit depending on the resistance offered by the circuit to the voltage signal. Similarly, the pneumatic circuit may offer resistance to the pressurized air, hence reducing its pressure as the air moves from one location to the other location. All the pneumatic systems utilizes pneumatic transmission medium to route the information from one device to the other device. Transfer of information between the sensors, the system, and the actuators as well is done using pneumatic systems. This type of signal transmission is one of the most common transmission medium that is used in especially FMCG industries. This topic is quite vast and therefore it is expected that the students have or can find these things in a course related to hydraulics and pneumatics. The third way that I am going to discuss is related to the use of electromagnetic waves to transfer the information. There are various methods that can use different electromagnetic waves to establish the communication. For example, some use radio waves, the other use microwaves, whereas there are methods that utilizes the IR radiations, yet another utilize the visible light, and few utilize even higher frequency electromagnetic waves. Over here, I am going to talk about transmission medium that utilizes either the visible spectrum electromagnetic waves or the IR spectrum electromagnetic waves. Firstly, talking about the visible spectrum or electromagnetic waves, this transmission medium offers several advantages. For example, they are safe, they have no hazard to any human worker, they are fast, that is, they have the speeds equivalent to electrical signals, and if properly managed, chances for noise induction are quite low over here. Therefore, these methods are quite robust. The only disadvantage associated with using visible light spectrum for transmission of information is the cost of the equipment. If visible light is transmitted through air, then interference with other sources of light can easily corrupt the signal. Therefore, transmission of visible light through air has a limited application. Just to name a few, the information from a multimedia projector is transferred to the projector screen is an example of visible light traveling through air. If you have been to cinemas, you can easily appreciate that if the lights of the cinema hall are on, then you cannot see the movie on the screen. And why is that? Because the light moving from the projector to the cinema screen is being interfered by the light from the light bulbs or any other light sources present in the cinema hall. Therefore, it is a necessary condition to turn off all other lights so that light coming out of the projector can reach the screen uninterrupted and without any distortion. Moreover, you can also appreciate that this kind of transmission through light has a very limited range. However, if you want light to travel to a much farther location and without any interruption from the surrounding light, then you should allow the light to move in a special container or a medium. I can relate this thing with another example, that is of the train system. If you want to move from one location to a very far location, then going either on foot or through roads is quite a challenging task. Whereas if you load yourself onto a train, then that train will take you to your final destination in a much shorter and robust manner. And then at the location, you can unload yourself from the train. The same methodology is followed in case of light. At one end, the light is loaded into a high-speed robust medium. The light travels in that medium safely, and when it reaches the other end, over there the light is taken out of that medium and converted back to either electrical signal or any suitable form. This special high-speed medium is called fiber optic cable. Specifically, there are three different scenarios which may arise for signal transmission. The first one is when you want the signal to be transmitted in a very short range, that is from a sensor to the signal processor which is located nearby. In the second case, this transfer of information might be at a bit longer distance. An example of this may be the local area network established in some institute. In this case, the information from each node or each instrument is routed to some central processing unit or central area where it is processed or analyzed. The last situation is when you have to route the signal to a very far location. For example, data transmission in telephones or computer networks. The fiber optic cables can be used in all these three situations just like any other medium. But for all these three situations, the demands for fiber optic cable properties will be different. Therefore, a fiber optic design for short runs or for communicating information over short distance may not be used for communicating the information over the long range, and vice versa as well. The discussion of fiber optic requires a proper dedicated portion. Therefore, I have separated the video discussing the fiber optics from this video and have provided the link in the description below. You can continue with this video where I will discuss transmission mediums of other types, and then later on you can view the referenced video for details on fiber optics. I've talked about this kind of signal transmission through an example of how signal is projected from a projector to the projector screen in a cinema hall. Formally speaking, this kind of signal transmission is called optical wireless telemetry because over here we are going to use visible light without any electrical or fiber optic cable. Before the invention of fiber optic cables, the information transfer using the visible light was already developed. Basically, there are three different modes of optical telemetry. The first one is point to point. In this mode, we are going to use a focused light source, just like a laser light, to transfer the signal from one location to the other location. The systems utilizing this kind of transmission can have a speed of about 5 megabits per second at a distance of approximately 1000 meters. However, if you want to increase the transmission speed, then the transmission distance has to be reduced. Normally, these kind of systems are used to connect electrical or fiber optic Ethernet network in adjacent buildings, where you cannot have a wire running from one building to the other building. The second mode is called the directed mode. In this mode, the light beam that is used is a bit divergent so that it bounces off different reflective surfaces. Although this mode has a wide coverage area and signal can be received at multiple locations, but it comes at the expense of lower transmission speeds and lesser transmission distance. The last mode is called the diffused mode. The example of this mode is exactly what a multimedia projector is doing. It has a large coverage area but lower transmission speed and distance as well. The fourth and the last way that I am going to discuss related to signal transmission mediums is formally called radio telemetry. It will use electromagnetic waves but of radio or microwave band. The use of radio waves offer a number of advantages as compared to the use of visible light for signal transmission. The very obvious advantage is that it can pass through obstacles. Moreover, it has a much higher range and is quite less prone to attenuation because there is nothing present in the environment that can interfere with a radio signal. Lastly, and I guess the most important advantage is that the radio transmitters and receivers can be built in a small size so that they can be mounted on mobile devices. So you won't have to carry big bulky transmitters or receivers to achieve the signal transmission. There are a number of techniques that can be used to transmit radio signals between the instruments, but transferring the radio signal without any kind of modulation is definitely not one of them. So whenever you want to transmit the radio signal, you have to modulate it. And over here, there are a number of ways to modulate the radio signal. Three major ways of modulation are called amplitude modulation, frequency modulation, and phase modulation. Frequency modulation is, however, the most used modulation technique around the world. It is because of this modulation technique that we are able to transmit thousands of channels simultaneously in a common medium, that is the air. All radio or TV channels are using this kind of modulation to transmit the signal. You know that on your TV, signal of no channel interfere with the signal of another channel. Moreover, same thing can be observed on the radio devices and more importantly on mobile devices. The trick in the modulation is to encode the information in some attribute of a high frequency signal. For example, in case of amplitude modulation, the information is hidden in the amplitude of the carrier signal. This carrier signal is normally a high-frequency sinusoid whose amplitude is directly dependent on the modulating signal. The signal that we are trying to transmit from one point to the other point is in fact this modulating signal. The net result of modulating is a carrier signal with modified amplitude. This modified signal is called the modulated signal. The modulating signal rides on the carrier signal just like as you ride on public transport and get off at your destination. Similarly, the modulating signal will leave the carrier signal at the destination and the device that caused the modulating signal get off the carrier ride is called the demodulator. On the contrary, if the modulating signal is doing nothing to the amplitude of the carrier signal, but it is changing the frequency of the carrier signal, then this thing is called frequency modulation. Now, the frequency of the carrier signal is dependent on the modulating signal. Hence, now the modulated signal will have a variable frequency or the frequency dependent on the signal that we want to transmit. The demodulator at the other end will extract the modulating signal or the signal which we wanted to send by decoding the information hidden in the frequency of the modulated signal. This flow graph shows the overall process followed by the radio telemetry application. Over here it is shown that there are 18 transducers measuring different types of data. However, in practice this scheme or this technique can be scaled up to millions of devices. Each transducer will generate a data and that data, or we can say a low frequency data that can be an analog or digital data, will be used to modulate a carrier signal. If you are using amplitude modulation, then the signal generated by the transducer will modulate the amplitude of the carrier. Whereas if you are using frequency modulation, then the data coming from the transducer will modulate the frequency of the carrier signal. So once modulation has been done, using the mixer and the frequency multiplier, the data is ready for transmission through antenna. Over here you can see that 18 different signals are being routed from the same antenna and they won't interfere with each other because each signal is modulating a carrier of a different frequency. You can imagine this thing through an example that let's suppose that there are four persons and they want to go to some destination but they cannot travel with each other. So the only option you would have is to book a separate transport vehicle for each one of them. Now they will move on the same roads in the same city but they cannot interfere with each other. Similarly, data coming from 18 different transducers are riding on different carriers, therefore these signals will not interfere with each other. At the receiving side, the antenna will receive the signals and a frequency divider will divide the signals based on the carrier signal. Now the information hidden in the amplitude or the frequency of the carrier signal will be extracted by the demodulator and that information was your original signal which you wanted to communicate. You must be wondering that how many different kind of carriers someone can use so that signals being routed in a common medium, that is the air, does not interfere with each other. Well, let me tell you that there are millions and millions of carrier frequencies that can be used. Moreover, there are national agencies that are responsible for allocating frequencies to the customers for specific use. For example, the TV channels are routed at different frequencies, and those frequencies are allocated to each TV channel. No TV channel broadcaster can use someone else's frequency, because if he does, his signal is going to interfere with the signal of some other TV channel, and ultimately both signals will be distorted and destroyed. Same is the case for mobile communications. No two mobile companies can use overlapping band of frequencies to establish communication between two devices. In fact, each SIM card has a different frequency, which makes sure that you only receive your calls and not of some other guys. For Pakistan, the Institute of Fab is responsible for allocating frequencies to different customers. Fab stands for Frequency Allocation Board. Secondly, there is another way to avoid overlapping or interference of signals, and that is to limit the signals in a certain region only. You must have seen this thing for radio channels, because normally radio channels are limited to a certain province or a certain city only. So if you are listening to FM 98.6 in one city, then you might also be listening to FM 98.6 in another city, but that might be a totally different channel, because the FM 98.6 channel in one city does not have enough power to cross the borders of that city. This makes shows that the two users using the same frequency to transmit their signal can work without a problem. Just as a side note, normally in radio stations, FM 98.6 means that this channel is using frequency modulation with a carrier wave of 98.6 MHz. You must have also listened to AM channels. Over there, AM stands for amplitude modulation. And you must also appreciate that AM channels or the AM modulated signals have much larger range as compared to frequency modulated signals, because AM channels use low frequency signal as a carrier signal. The range the signal can travel is inversely proportional to its frequency. That is why scientists are using radio waves for communicating with some extraterrestrial life, because radio waves are of much lower frequency than other electromagnetic waves, and hence they can travel much farther than other type of waves. Moreover, you must have listened about the buzz of 2G, then 3G, 4G, and then 5G as well. 1G was even before you were born or even I was born, so we might not have heard about it. But we have definitely heard about 3G, 4G, and nowadays 5G. So, what is this all about? All these generations are based on the band of carrier frequencies that are used for transmission of signal. As I have already said that the frequency of the carrier signal is inversely proportional to the range the signal can travel. So using a higher frequency signal will reduce the range of the signal that it can travel. However, the data carrying capability of a signal is directly proportional to the frequency. Frequency means that in how much time one complete oscillation a signal is making, that is, from positive to negative, and then again to positive. If signal is oscillating at a fast rate, then it means it can represent more ones and zeros, or you can say more positive and negative numbers in a second. A 20 Hz signal will oscillate 20 times in 1 second. That is, it can represent 20 positive numbers and 20 negative numbers. If we relate this thing with digital communication, then each positive number might represent a 1, whereas a negative number might represent a 0. So at 20 Hz, signal can convey 20 ones and 20 zeros in 1 second. Although this is not how things progress, but I am just trying to make sense that how things are working. Now suppose that instead of 20 Hz, you have used 20,000 Hz. Then what is going to happen? In the same 1 second, 20,000 ones and 20,000 zeros can be transmitted. You can now say that you have increased the frequency, or in turn the data carrying capability. However, by increasing the frequency, the range the signal can travel in the medium will decrease. Using a high frequency requires fast modulators and B modulators so that they can work with a rapidly varying signal. Therefore, in 1990s, in the era of 2G, we would not have seen so many antennas or mobile communication towers in our cities. That was because the carrier signal used for 2G communication was of quite lower frequency, and hence it can travel much farther, so you don't need antennas or boosters all around the cities. And as we are using low frequencies, the data carrying capability was quite low as well. After that came the 3G technology. So we upgraded our systems, we used latest modulators and demodulators, and our mobile devices changed. Hence, we were able to communicate using a higher frequency carrier signals. This increased the data carrying capability but decreased the range the signal can travel. So we started seeing mobile towers, TV antennas, boosters, and all such things around our cities. Now when 4G came, we started seeing more and more towers because the range of the signal has decreased even more. But the data carrying capability has increased quite a lot. At 4G, we were at the brink of radio frequencies of electromagnetic spectrum. We wanted to increase the speed even more, but we were out of radio frequencies. So we stepped into the new era by using the microwaves for the first time to transmit signals on a network. Microwaves have much higher frequency than the radio waves, therefore the range is quite low, and in the cities where they have installed 5G networks, people can appreciate that there are signal boosters and repeaters installed on almost every street. Now the data carrying capability has increased quite a lot, but the range has decreased abruptly. There are forums that are still discussing that is 5G technology hazardous to our health? Because microwave radiations are the same radiations that are used in a microwave oven to heat up your food. Of course, the microwaves used in a microwave oven have a much higher power in them as compared to the 5G microwaves. So if these microwaves are used to route signal data in our cities, then is it going to affect the overall temperature and hence the health of our earth and the humans living on it? Or is it in the safe frequency band and the power range? This debate is still going on, but governments have already allowed network companies to install 5G networks because we are moving towards completely automated world where we need high rates of data transfer, and that can only be provided by the use of microwaves. I feel that if we are not satisfied with the speeds of 5G network, then what a 6G network would use. With this, I would like to end this video lecture. Thank you. Take care.